So first of all, happy Pi Day. It's 14th of March, of course. So then to who am I? I used to be a molecular biologist. That's why I went to university for. Even in molecular biology, big data made its introduction, so I quickly moved over to the dark side and became a developer to deal with that sad data. In the end, in academia, most of the time, the developer guy is also the server guy, so I sold my soul to the dark side again and became the ops guy. And now I work for a Belgian consultancy, but I work for the Dutch office in Rotterdam. Today, I would like to discuss some of the tools in the HashiCorp suite. I do not work for HashiCorp. We do not get sponsored by the HashiCorp tools of HashiCorp itself, but we do like the tools. Now specifically, today I would like to discuss how they could interact or how we interact with these tools and Icinga. First of all, Vagrant, the original HashiCorp tool, it's an open source tool that helps you bootstrap VMs. Everybody used to have a golden image somewhere and then bash scripts to get it to work. Vagrant is a very simple way to have a local development setup. Back in the days, it was VirtualBox. Nowadays, most people use Docker or even run it against AWS. It has loads of plugins. It is plugin-based system, so it has plugins they call provisioners for most of the provisioning tools like Puppet, like Chef, like Ansible. You can basically freeform your own definitions. There needs to be a file called the Vagrant File. It's basically pure Ruby, so anything that's allowed in Ruby, you can do in here. It has certain amount of predefined configurations things. For instance, the only one that's really required is basically config.vm.box. That describes which base image you're going to use, because still it's old school virtualization technology, so we do need some form of base image. HashiCorp has a tool to build those base images, but today I'm going to mention it, but I'm not going to show you exactly how it works. So in here, there's a couple of configuration features that have been commented out, but you can pretty much configure it the way you want. You can configure the network, public or private. You can have directories easily mapped from your development system into the VM, so you can develop on the outside while host it or run it on the inside. You can have, for the base providers, in this case it will be a VirtualBox. You can turn on the UI, basically saying I want the full OS where I can log in, where I can have the UI, or you can set memory. And then, of course, you can have the post-installed provisioners. Or in this case, Apache will be installed. But you can make this as complicated as you want. The Icinga project has several nicely defined Vagrant boxes for you to try. So if you don't have any time or space or etc. to build your own, you can easily get those. They provide a couple of iterations. They have a standalone. They have the one where you can, a distributed one where there's a master and slaves where you can test those around. And then there's couple other versions where they have integrations with other tools like InfluxDB, like Elastic that we've seen before. You can build your own. Further in this talk, we'll see that I have built my own. But yeah, use the one from Icinga. They come with actual docs. And username passwords, URLs you can visit. They're really nice. That's how we got started with Icinga too. Just spin this up, give it a try. If you like it, build out your own. The other tool is called Terraform. One of the other tools is Terraform. Terraform is basically it's also open source. They have a proprietary product on top of it, but most of it is open source. Again, it's plugin based. it's oriented towards the cloud. When cloud is a undefined subject, of course, but in cloud, they mean anything that has an API that we can talk to that basically have CRUD operations. So we can build out entire infrastructure, but we also, for instance, can build or define Icinga resources. Terraform uses a very simple workflow. You model your infrastructure in a desired state, so you have resources of type X, which you then plan, where Terraform goes out to the provider you've requested, and then comes back saying there's going to be X additions, that many removals, or nothing is going to change. If you're happy with the plan, you can apply it, and then you'll be given a state file for future reference so that it actually knows what it did and what it will be changing. There's ways of storing this state into a distributed bucket at AWS, for instance, and then you can work on it as a team, and then we're pretty much basically back to the Puppet workflow where whole teams can write code, test code, and deploy it. Terraform uses a language they came up with themselves. It's called HCL, the HashiCorp configuration language. It's pretty much similar to any config management DSL you know. As I said, you have resources, and it's based on a desired state. So if you run Terraform, it will try to breach your desired state. If it doesn't, it errors out, and then it will make the author fix his problem. It doesn't try to over and over to fix it, it will just error out. Currently it's being used by many of the HashiCorp tools itself. There's also starting to widely adopted into third-party tools. So Icinga has its own provider. The way to start is fairly simple. You say it's provider of type Icinga 2. Because this is my Vagrant box, I don't care that I show you my super secret password. But normally you would stick this in a file, TF. You either export it onto your bash, or you stick it in a TF file, which you then exclude from your Git repository. Again, it's my local Vagrant box, so I don't care that the TLS is not working. And that's basically it. Those are the first things it needs to know. It needs to know where Icinga lives. It needs to know how to get in, and it needs to know if it can trust your certificate. The default is no, so if you have it set it up properly, then it will work. The most important resource in my world is the resource of type Icinga 2_host. Here I build a simple one where I said node 1. That's just the descriptor in your Terraform code. It needs to be unique. That's how Terraform works out. If all of your resources are unique, because that's the only way to reach desired state. If there's ambiguity, if there's two nodes with the same name, then it can't work out which one it needs to be. So everything needs to be distinct. The host name itself, that's what the tool will use to make sure it's a distinct resource. And then again, there's a simple host alive check here that I'm going to set up, and then I'm going to assign a couple of vars. The most important one, this is my Linux node, so it needs to be in the group Linux nodes. Icinga 2 also has a resource called Icinga 2 host group, which is nice, but at the moment it lacks the features, I think, because I didn't manage to get it to work, to assign nodes with a certain variable set. That's how we normally do it, to get around the Puppet exported resource taking too long problem. Speaking of which, the way if you terraformed a node, an actual node in this case, it's Amazon, we can directly go, instead of having to do your first Puppet run, have the node export its resources, then Icinga needs to have a Puppet run. And then, only then your nodes are being monitored. So if you use the Icinga Terraform provider, from the moment your AWS resource has been instantiated, you can immediately go into Icinga and request the API to start monitoring your new node. And that, in our case, our Puppet runs are really slow. Sometimes the timing is off, so in our case, it can take up to 75 minutes before monitoring comes online. If you do it this way, it's minutes. Sometimes it's too fast, and then basically your Icinga will light up red because the node's not actually online yet. So be aware that you might have to do some neat tricks with scheduled downtime. Of course, we can have all the other resources. You can have check commands. So what do I need to check? How will I check it? A couple of arguments that also can be taken from as outputs from any of the other resources you have, and services. And the services then can be linked to your check commands. So instead of having to build big config files, you basically mix and match resources that then by the API gets folded together. Notifications, previous speaker also mentioned it. A monitoring tool is useless if nobody gets woken up. So we also need to be able to describe users. We need to have the ways people want to be notified. And again, we have some LDAP tools, but basically we create a user in LDAP and we also create a user in Icinga. We have the check command, and then let's demo a little box. This is can everybody see? This is my little Icinga, my Vagrant box, so I can destroy this at will. So I've set up some Terraform stuff before. Okay. Terraform uses a certain extension called TF. And if we look at that file, what we're going to do, we're basically going to set up this provider again. We're going to have a Icinga host, the one we've been describing before, and we're going to set up a host group. First of all, in Icinga, Terraform is a plugin-based system, but you do not have to pre-install the modules. It will, if you perform a Terraform init, it will basically parse your code. It will work out which plugins you do have, which ones you don't have, and then it will try and download them from the internet. So Wi-Fi is still stable. Here, it worked out that we have defined the provider Icinga 2. It downloaded successfully from the internet, and now it's available in my local repository, local directory. So if you have a ls, we basically now have a .terraform folder where most of the stuff is built in. We can now have a Terraform plan. And I screwed up. I was experimenting with outputs, which doesn't work because the module itself at the moment doesn't have outputs. So now we see that Terraform actually it parses all the files in, it parses all the TF files in there. So there's no nice way of doing object-oriented-ish development. It's just it parses all the files and it tries to work out the correct order. So we can plan again. And it will actually come back. It will tell us it wants to add 2 new resources, and it will describe the diff before that. Let's see if it's still empty. So at the moment, we only have 2 nodes, which is my Puppet master and the Icinga node itself. And if we apply this plan now, it always asks you to do yes, or if you do dash auto approve, it will do it in one go. So if you want to go YOLO, then add the auto approve. And we already see that node 1 has been added to our Icinga setup, and it's actually being checked right now. And the checks are already green. Here. And at the same way, if we want to do, we want to not leave any mess behind for some poor person at 3 AM to work out, is this node still alive or is it just acknowledged? We can now also cleanly delete all the stuff we set up. So terraform deletes, destroy, sorry. Boom, everything's done. I should have planned this, but again, Vagrant Box, YOLO, sure, and we just saw it being cleaned up as well in the interface. So if you have quickly changing infrastructure, this is an ideal way to set up your cluster and still be in sync. Because this way, all your configuration is in one place. If you start putting stuff in 2 different repositories, it's up to a human to keep the 2 in sync. And the way we do it, if you do it this way, then at least everything is in one place, so you cannot forget to add something. That brings us to Consul. Consul is another open source tool by HashiCorp, which is a service discovery tool. It basically allows people, or allows nodes or services to self-announce that they are part of something. For instance, I am a MySQL server, so you do not have to define what the IP address is or what the vanity FQDN is of your MySQL server. You'll just basically connect to another vanity URL which is hosted from Consul. It uses SRV records to announce services available. In this case, I can actually ask my local Consul server, like, where's my Puppet Master? I'm not going to use puppetmaster.mydomain.com. I'll just going to ask, where's my puppetmaster.service.consul? And that way you can easily add and remove Puppet Masters without actually just having to go into your entire infrastructure and fix it. Because hardware dies, and servers dies, new data centers get started, and this way you can easily control where your traffic is going. It also has a built-in key value store, and in the latest version 1.4 it actually gained abilities to be a mesh controller thingy. So you can actually set up rules which nodes can contact which services. It's all ACL based, it's all yeah. So it's very nice if you actually want to prevent people from actually discovering your services. Also, the biggest example there is my acceptance servers will never ever be allowed to discover my production clusters, and this way you can actually set up your mesh in such a way that your staging will never ever get to production without having to put firewalls in between. Well, you actually are putting a firewall in between, but we now call it the mesh. So from this bit onwards, we're going to have a bit of a Puppet overload. Consul is very easy to set up. It has a module on the Forge. It's well liked. It's pretty well developed. It's simple inclusion. You add a hash with configuration options, and then it starts building. You can define services in Consul, so you can also define Consul services in Puppet. It's a defined type, where I basically say I have a service that is called, in this case, it's called Puppet Master, and it will listen on port 8140. For all servers, there needs to be at least one check. And the check basically works out if your service is still online. If the check fails, it will actually pull that node out of your service. So there's no, you do not have to put complicated bash scripts or other tooling in place that basically pulls nodes out of services. That way you can still serve your customers while be able to recover your nodes. So in this case, I have set up a check here, or defined a check that I want to check my localhost 8140. That's where your Puppet Master will be listening, and that I need to check it every 60 seconds. So at worst, my Puppet Master will serve or won't serve traffic for 60 seconds, and then the check will happen, and then it will be taken out of the pool. This is, so why is Bram talking about Consul so much? Consul is actually, when it was written, the guys at HashiCorp actually had to work out a way to work out what exit codes to use, and they politely used the same exit code as Icinga. So you can actually use all your existing Icinga checks to do your Consul checks as well. That basically means that you only have to write one check that you use for two purposes, and it basically, you don't screw up by having to implement it twice, and you can use it everywhere, so you know the result will always be the same. People say, I implemented it twice and the result will always be the same. You always have race conditions, and now you're down to basically the one race condition but on a well-developed plugin that basically the whole world will run. Here I show you an example for Postgres. It uses the built-in Icinga check, and it makes sure it checks port 5432. Again, then it came up a couple of times today, so I'm glad I left this slide in. Puppet has a system called exported resources, or basically define a resource on one node and then express it on the other. And that's how Icinga checks are mostly defined. So on my Postgres server, I'll define an exported resources check Postgres, and then on my Puppet Master, it gets expressed. As I said, and previous people said, it actually takes quite a long time for these to express. So if there would be a way for my service discovery to tell me there has been a change in this service, so I actually need to perform something now. A Consul built in a thing called Consul Watches, where it can basically watch a service for changes. So now in our case, we don't actually wait for the second Puppet run. What we do is, we also use Prometheus, so every node gets a Prometheus exporter. That's the endpoint where it will announce its basic metrics. So we know if a change happens in the node exporter service, we know there's either a new node or a node has left our infrastructure. So we watch this node exporter, and what we then do is on the Icinga masters, we actually trigger a Puppet run. And that saves us at least half an hour. And in this case, it triggers Puppet using a little shell script, but the only thing it does is basically Puppet agent minus T. And this is the bit. So due to some weather troubles yesterday, I showed up in Berlin 8 hours early. So I had some time to do some conference-driven development. So that's what I'm going to share right now. Because I thought, what would be better than actually waiting for a service to show up and then trigger Puppet, etc., etc. Wouldn't it be easier if I know that this service, if something happens there, I have either new nodes or I have old nodes? Why don't I bypass Puppet and directly use the API for Icinga? So we can save on this Puppet run. At Inuits, we We actually don't use export as resources very much anymore. We basically have nodes express vars, and based on the vars, we have service groups. So could I write a director sync plugin that directly writes, imports my nodes into Icinga? Making a module in Icinga is quite easy. You go to the designated modules directory and you make a directory with your plugin name. I named it Consul, because it is. Then for modules, it actually will show up in your Icinga configuration already, but you need to have 2 files in place to actually do stuff. This one isn't entirely necessary, but it's a nice way to actually tell people what it is you're building. So name console, imaginary version number, and it requires director to be installed, and a little bit of information. The other one is a run.php. We now live in the time of namespaces, so we use the appropriate namespace, and we tell Icinga, over Icinga web actually, that we're going to provide a hook of type director import source. Icinga web is a very nicely written application that's still built on Xen Framework 1. Xen Framework 1 was a convention over configuration framework. So as long as you put stuff in the right place, it will be picked up and it will be executed correctly. So simple 2-liner to get started. You need another file somewhere in your library folder, basically library dollar module and then provider hook director, and then in that directory you need a file called import source. As far as I've been able to work out, you need 4 functions. You need to give it a name so that when you use it in director, it actually has a nice fancy name. You need a way to fetch data. You need to show the columns for use in the previews, and you need to be able to give a default key column name. So let's work out what code we were required to put in place to get this working. We need a little bit of config, as I said, default column name. In the case of Consul, you're going to have a JSON array, and we're looking for the key name that will actually tell us what node to add. I also found out that I want to specify where my Consul cluster is. Normally it runs on localhost 8500, but some people run it in weird places. So I worked out that you can actually add form fields in this already existing form by calling the function add settings form fields, and then add an element there. Here I'm going to add a simple text element with a default value of again, localhost 8500, where I expect it to show up. We're not cavemen, so back in the days when you want to vendor external code, you would just untar it somewhere in a folder and commit it into your repository. Even in the PHP world, we've grown up and we've worked out that we need a package manager. In PHP world, it's called Composer, and we want to use an external SDK already. Here it is still Sensio Lab, so it's the guys behind Symfony as well that developed it, but it's actually moved over to Friends of PHP. So if you Composer require it, it gets installed into your local vendor folder. It will create a log file, so even if I don't commit my vendor directory, actually the next person can work out what version I've been using. And this is the one where I've got stuck the most. Actually, in your run.php, you now need to add your local autoloader. Composer will build an autoload file, and that's basically a list of locations and file names. So in our run.php, this extra line require once my autoloader. How do I get now my code of my list of nodes out of Consul? That's where the fetch data comes in. And this is basically a little code sample. You need to have a certain service factory where I now pass in the URL that we set up in our form. So that's a simple dist-get setting, and then that's the form element that automatically gets saved into the database, so I do not have to write any settings or any files. I don't have to write any database connectors. It just automatically works, which is very nice. Then I need to, if I have my service factory, I need to get the agent, which is basically one of the namespaces that Consul has, and then I request the members, in which I get the body, because if I just do members, you actually get a lot of information about headers and that kind of stuff. So I'm only interested in the body. That's going to be a JSON string, which I'm going to decode, so now I have a PHP array. And that array I can then pass around in the list columns function. I hope you can see this, but this is basically now we're in Icinga director, and we're adding a new import source of the type HashiCorp console with, again, my default column name that we defined and the HTTP API endpoint. Not when you do import sources, I've worked out that you also need sync rules. I'll have one defined, which is basically look for my hosts, and I bind the type host to this check, and I'll say replace default policies replace and yes please for purchase, so that when nodes disappear, I'll also remove them from my cluster. This is the other bit where I got stuck quite a while. We'll need to map a couple more things to this sync rule. I need to map another key from my JSON array onto a thing in Icinga. So I need to map the address variable to the address destination, and I need to assign a simple basic template. So now we have our working sync source. But now this still requires manual intervention where I have to click a lot in the interface to get my nodes in there. So what I will now want to do is set up this Consul watcher that we discussed before, but now specifically to sync Icinga. Again, we're watching the node exporter service because that's our most reliable source of information about our nodes. First of all, sorry for the people that don't speak Puppet, but the first resource here says I want a file on my system at a certain location and fill it with the content of a file that's on my Puppet master, and make sure Consul is the owner and it's executable. Then Consul watch will then use this file, this executable to actually sync my sync Icinga. So what does the script look like? In the end, it was actually quite simple. I need to make sure that my import sources gets run, my sync rule gets run, and then my convex needs to be deployed. So another demo. And so this code was finished during lunch, so please bear with me if it doesn't work. Okay. So let's go one folder up. We SSH into node number 2. And these are set up with Puppet with Consul disabled as default. So I now need to actually of course. So I need to disable Puppet so that it doesn't actually turn off Consul again in a minute. So I turn off, make sure Puppet doesn't come back in, and fix my configuration and then start Consul. Consul already has this node exporter configured in there. Let's have a look there. So in my case, all the configuration files are in etcd console. It has a generic config.json, and my node exporter configuration. Unfortunately, this is not pretty YAML, but it's basically where is my node, what port to do what to. So I'll pre-provision this so that we don't have to look at scrolling green text on black background. What does it say? So I need to disable Puppet and start console. And if this worked, then my node should show up any second now. Code worked. So basically, now we're down 2 seconds. I didn't time it, but we're now down to seconds for nodes to show up in your Icinga cluster. The next obvious step should be, of course, now I only ask the list of nodes, but give me the list of nodes which services, and then use these service names to export vars, and then automatically group them into service groups. Literally just push this. If you want to have a look, if you want to have a play, I pushed it to my GitHub. You should be able to find it there. That was pretty much it. Questions?
Do we have any questions? So everything's clear? You deployed it already? Oh, there's a question.
So you have on every node a Consul agent running,
yes,
and therefore you get the Puppet server URL. But how do you deploy the Consul if you deploy it with Puppet and the first Puppet run has no server?
Yes, good question. Let's see where that slide is hiding. So I am early, so I can actually switch into some bits I provisioned before. I have another talk called Puppet and the HashiCorp stack, and this is actually where I explain this. Let me find it. We have a chicken and egg problem. It's a DNS problem because you do not, even though you have Consul, you do not know where Consul can be found. If you're here we are. This is a cloud init script, and basically most Consul has a nice built-in tool where you can go out into your cloud provider of choice and basically ask, give me all the nodes that are tagged within the name Consul or variable X, and then give me all the IPs that belong to there. And that's how you bootstrap your Consul in your pre-cloud days. You still have to specify one IP address at one point.
Okay, thanks.
Any more questions? All right then. Thank you very much, Bram.
Okay.